All right, so this is section 1.1, and in this section, we're going to be talking about angles. So let's define it. An angle consists of two rays in a plane with a common endpoint, or two line segments with a common endpoint. Here's an example. Here's my common endpoint, and these are two rays that come from that endpoint. So this is considered to be an angle. Let's review some things about angles, like if this is, an X point, Y, and Z, you can identify this angle as angle XYZ. You could also say angle ZYX. And because there's only one angle existing here at that point Y, you can also call it angle Y. If there was a number inside of this angle, right here, like 1, you could also identify it as angle 1. So those are some ways for us to name angles, which you're familiar with from your work in geometry. All right, measuring angles in a counterclockwise direction, so that would be rotating towards the left. This would give us angles in that have a positive angle measure. And if we measure an angle in clockwise, so that would be rotating towards the right direction, that results in a negative angle measure. Okay, let's look at this also. So if I've got an angle, let's do a coordinate plane, XY. And if I have an angle here, let's start it at my x-axis. So angles that rotate counterclockwise, okay, these are all positive measures. And then angles that rotate counterclockwise, that would be a negative measure. Those are negative angles. All right, we have different types of angles. We have acute angles, we have a right angle, and we've got obtuse. So let's review the measures that are going to be tied to those. So an acute angle is an angle that measures between 0 and 90. Between 0 and 90. So an interval that would look like this, so an inequality, x is between 0 degrees and 90 degrees. So not including 90 there, not including 0, but between. If you're looking at a right angle, that would measure exactly 90 degrees. So that would be your x, your angle x would be 90 degrees. And for an obtuse angle, you're going to be between 90 and 180. And again, these are all little degrees. Here's an interval for us in an inequality. So between 90 and 180. You can see that those inequalities represent a statement that tells us the measure of the angle. A straight angle is going to be exactly 180 degrees. A straight angle, so x would be equal to 180 degrees. That looks like this. So we've got an angle. Maybe the vertex is in the middle here. That's an 180 degree measure. Rotate it counterclockwise. This is 180 degrees. A straight angle is going to be a line. That is another description for that. We also have complementary angles. Complementary angles are two angles whose sum is equal to 90 degrees. Complementary angles, two angles that add to 90. Here's a set of complementary angles. We've got, let's go ahead and put those two angles together. Let's say we have an angle measure of 80 degrees here. And then we've got another angle measure of 10 degrees. So their sum totals 90. So that would be, these are complementary. And then, of course, we've got angles that are supplementary, two angles whose sum is 180. So remember what the word sum means. Sum means that you add them together. It's the result, the answer in addition. And then you can, let's go ahead and go along with this straight angle right here. So if I have two angles that add to 180, let's say those two angles are like 130 degrees and maybe 50 degrees. So those two angles would be supplementary. All of that, some prior knowledge, just let's work with the angle and their measures. We also are going to introduce something new, though, and that's the parts to an angle. And parts to an angle are things like minutes and seconds. Okay, so we most commonly refer to angles that are in degrees, right? That's the label for it, kind of like we have feet and inches and seconds. We've got hours. Well, in angles, we talk about the degree. But the portions of a degree may be expressed either as a decimal, or you can write them in what we call minutes and seconds. So here's some conversions. In this first part, or here, we've got, this represents 1 minute is equal to 1/60th of a degree. I like to also show it this way. 1 degree is equal to 60 minutes. We can do that in a conversion ratio. 1 degree is equal to 60 minutes. And then, of course, we've got, this is 1 second. 1 second is part of a minute. And there are 60 seconds in a minute. So we've got 1 minute. Minutes, we use one little hash mark there. And then that is equivalent to 60 seconds. So again, 1 minute is equivalent to 60 seconds. And so you can see there for the seconds, we use 2 hash marks. That's that smaller measurement. We will be doing some conversions and using the minutes and the seconds as we work through examples. An angle in standard position, we call it standard position, has its initial side on the positive x-axis. That's here, positive x-axis. This is our initial side. We'll go ahead and draw our x and y axis. And you've got, here's our initial side on the bottom. Initial right here. It's on the positive x-axis, and we call it our terminal side. Terminal just means where it stops. The terminal side of our angle will be in one of the 4 quadrants. So we are going to rotate clockwise here, and let's say I end my angle here in the 3rd quadrant. Then this would be our terminal side, again, where it stops. And then our angle measure here, we call it, usually a lot of times our angles are in theta. It's a Greek letter that we will use. That'll be our degrees. Angles with a terminal side that lie on the x or y axis are called quadrant angles. Quadrant. So this would be like a 90-degree angle. So if I want to draw a positive 90-degree angle, if I start on my x-axis, positive x-axis, and then if it terminates here on the y, positive y-axis, this angle right here is 90 degrees, and it's a quadrant angle. So it ends on one of our quadrants. We've got a quadrant angle of 90. We've got a 180. The next quadrant angle here would be at 270. and that would be like down here at the bottom. So we've got, I'll label these measures at the top. We've got 90 degrees, we've got 180. If I add 90 again, that's 270, and then of course back to the beginning, which is 360, which is a full revolution around. So each of these here are our quadrant angles, and it can make a full circle. Okay, coterminal angles. Coterminal are angles. They coexist, right, on the terminal side, and so that's where that word comes from. But they are angles that are the same angle with different degree of measures, and they are found by adding or subtracting 360 degrees from the original. So they are in the same location. If I look at, one more time here, let's do our X and Y axis. Let's say I draw an angle that is at positive, so I start here on my x-axis and it ends up here, let's say at 100 degrees. So this is 100 degrees. Then we could have another angle that goes in the negative direction. So starting at the initial side, rotate clockwise around to the same terminal side here, and that angle would be equivalent to negative 260 degrees. So there's two different angles there, but they are starting and stopping at the same place. And a way that we can find, again, a terminal angle is by either adding or subtracting 360 to the number. So in this case right here, if I started with my first angle, 100 degrees, if I subtract 360 degrees, then I have a coterminal angle that's negative 260 degrees. If I wanted to start and stop at the same location, but maybe make a full revolution, I would go around to 100. And then if I continue around again, and then I stop in the same terminal line, then that would be equivalent to 460 degrees. So this would be going 100 degrees. If I add 360 degrees, then I'm going to stop that angle at 460. Again, that terminal side is in quadrant 2 here, and they're all in the same location. So the best thing for us to do is just adding or subtracting 360 to get something that's coterminal. All right, looking at this next problem here, it says find the complement and the supplement of an angle with the given measures. So remember, complementary angles, they add to 90. And supplementary angles, they add to 180. And so we are going to find the complement and supplement simply by subtracting. All right, so if I do, first example, letter A, if I do 90 minus 43 degrees, then that is equal to 47 degrees, and that is its complement. If I do 180 degrees minus 43 degrees, then that's going to give me my supplement to the angle, and that is equivalent to 137 degrees. And so that's how you can find your complement and your supplement to the angle. Now, there is a shortcut that you can use when you're finding the supplement, and that is simply to just add 90 degrees to your initial complement angle. Let's go ahead and find my complement here. On letter B, 90 minus 85 is 5 degrees. So if I wanted the complement or the supplementary angle to that, then I could add 90 degrees to your 5, and that would be 95 degrees. So complementary angle, and then its supplementary angle. Now, when we start talking about the next two angles, we are dealing with some minutes and seconds, and so I'll show you how to subtract if you're given those secondary measurements. Okay, so I will show you in more detail here on C and D, like how we find the complement and the supplement. So let's start with angle C here. So if I want to do 90 degrees and I want to subtract 10 degrees and 15 minutes. Minutes, again, has the one little tally or the one little hash mark as its label. So here's what we do. It's like back in middle school math, maybe a little elementary school, but we have to borrow. And if I'm going to borrow from the 90, right, I need to borrow from 90, I get 89, and that is equivalent, then that one degree is equivalent to 60 minutes. Then I can subtract. I'm just going to subtract vertically. So 60 minutes minus 15 minutes would be 45 minutes. And 89 minus 10 would be 79. So we've got 79 degrees and 45 minutes. There's our complement. The label is really crucial here to make sure that you are putting those in there correctly. Let me show you how to do that from 180. So we got 180 degrees. We're going to subtract 10 degrees and 15 minutes. So let's borrow. So now we have 179 degrees and then 60 minutes. So again, we're borrowing a full minute or a full degree from the 180 and gives us 60 minutes. You can subtract, we get 45 degrees, and 179 minus 10 would be 169 degrees. There's my complement, and then again my supplement. Again, what you can do is you can add 90 to 179, and that'll give you the measure of your supplement. Just a shortcut that you can do. Okay, let's do this last one. So our angle is 68 degrees, 30 minutes, 12 seconds, starting with our complement. So 90 degrees minus 68 degree, 30 minutes, 12 seconds. Let's subtract vertically. We are going to borrow. So this would become 89 minutes or 89 degrees and then 60 minutes here. I have to borrow in order to get to my seconds. So 60 minutes, if I borrow from there, I'm now going to be down to 59 minutes. That gives me 60 seconds. So if I subtract, I'm going to get 48 seconds. 59 minus 30 would be 29 minutes. And 89 minus 68, if I subtract those, I get 21 degrees. So there's my complement. Let's write that in the first position. 21 degrees, 29 minutes, and 48 seconds. So the shortcut would be that let's just add 90 here. If I take this and I add my 90 degrees to get the supplement, we still have 48 seconds. We still have 29 minutes. And we have 111 degrees. So there's my supplementary angle. 111 degrees, 29 minutes, 48 seconds. So there are some conversions there with our minutes and our seconds. Again, they are portions of a full degree. All right, over to our second page here. We've got example 2, find the measure of each unknown angle. If I have supplementary angles, and the angle measures are 4x plus 10 and 6x minus 20. So first of all, I want to identify that they are supplementary. And so let's add them together. So 4x plus 10 plus 6x minus 20. Then I know they equal 180 degrees. That'd be 10x minus 10 equals 180 degrees. 10x would equal 190 degrees. X would equal 19. All right, so we've got our x value is 19. So the directions here, they say to find the measure of each unknown angle. So if I take that 19 and I plug it back in, I have 4 times 19 plus 10. And that would be 76 plus 10, which is 86 degrees. There's my first angle. My second angle would be 6 times 19 minus 20, and that would give us 94 degrees. And so you can check to make sure those two are supplementary to each other, and they do add to 180 degrees, but those are the two unknown angles. All right, looking at example B, two complementary angles. So complementary angles add, those are the ones that add to 90 degrees. And so we're going to write our equations, 3x plus 2x plus 15, and that is equal to 90. That's 5x plus 15 equals 90. 5x would equal 75, so x equals 15. Let's substitute back in. So 3 times 15, there's my first angle, that's 45 degrees. And then if I do 2 times 15 and then plus 15, that equals 30 plus 15, which is like another 45 degrees. So both of those angles are 45 degrees. All right, looking at example 3, use degrees, minutes, and seconds to perform the calculations. If we're just adding, again, I like to set my addition up vertically. So I've got 51 degrees, 29 minutes, and I'm going to add 32 degrees and 46 minutes. That gives me, I'm going to add vertically for the minutes. I get 15, carry the 1, and then 4 plus 2 plus 1 is 7, so I've got 75 minutes. And for my degrees, I have 83. And of course, we're over a full measure on that 75 minutes. So we'll turn that into 83 degrees plus 1 full degree. And then we've got the 15 minutes left. So we're basically taking 60 minutes off of that 75. Right here, this is our 60 minutes. We're going to carry that over. So then it's 84 degrees and 15 minutes. Oh, let's go ahead and subtract here. So I've got 90 minus 73 degrees, 12 minutes. So let's borrow. If I borrow from the 90, I get 89, and then that's 60 minutes. And if I subtract, I'm going to get 48 minutes. And then we would have 16 degrees. So this is 16 degrees and 48 minutes. All right, if we want to convert our 74 degrees, 8 minutes and 14 seconds to a decimal instead of using the minutes and seconds, this is how we will do that. First of all, I know that I have 74 point something. My degrees is 74 degrees. Now here's how we find that point something. What I like to do is I like to convert all of my minutes and seconds into seconds. So we're going to do 8 minutes times 60 seconds, and then we're going to add 14 to that. That is equivalent to 494 seconds. Okay, now we need to talk about the number of seconds in a degree. So if there are 60 seconds in 1 minute, and there are 60 minutes in 1 degree, then if I multiply 60 times 60, that's 3,600 seconds. That is equivalent to 1 degree. So where I'm taking this is that if I have 494 seconds, if you do 494 number of seconds and you divide it by 3,600 seconds, this will convert it to a decimal that's in degrees. So go ahead and divide that. And that final decimal will give you your measurement in degree, which is to the nearest thousandth is 0.137 degrees. Okay, so there's our conversion there. So I needed to take the minutes and the seconds, and I converted them to all seconds and then divided by 3600 to figure out that portion of a full degree. All right, we're going to convert 34.817 degrees to minutes and seconds. Here's how this works. So we already have our minutes. Our minutes is our degree. Our degree is 34 degrees. Let's take our portion, 0.817, which is our degree. If we multiply that by 60, this will tell us the number of minutes that we have. Degree to minutes. After multiplying that, I get 49.02. Now, because of the 0.02, that's a partial minute. So I know I have 34 degrees, 49 minutes. That partial minute needs to be turned into seconds. So that 0.02, if you multiply that part of a minute times 60 seconds, then this will give us the number of seconds. 0.02 times, now this equals 1.2. So we've got 1 full second. Now we always do 2-digit place for our minutes and seconds. So 0.01, we are going to round it off, drop off that 0.2 seconds. All right, our last part here to this section, it says find angles of least positive measure that are coterminal to. So just a reminder what coterminal means. Coterminal means that they are in the same position. The initial ray and the terminal ray are in the same position. We just might be rotating around a couple different times, or one's going into a positive direction, one's going in a negative direction. And a way for us to find it is either to add 360 degrees or to subtract 360 degrees. Now, because this says find the least positive, then that means we want the smallest measure, and by not going into the negative direction. We want the smallest measure, non-negative. So we're going to need to subtract 360 from 908 a couple different times. And then we'll see what we get for our result. If I subtract 360 twice, then I'm left with 188 degrees. That's the smallest coterminal to 908. If I've got a negative 75 degrees, I need to go to the smallest positive, so I need to add 360. And in this case here, because 75 is negative, then all I really need to do is take and do that addition of 360 one time, and that's going to give us 285 degrees. Always put your label. Negative 800, so I'm going to need to add 360 several times. Let's start with 2 and then see where you're at and see then if we have to do a third. It does look like we'll have to do 3 of them. If you add 360 to negative 800 3 times, you'll be left with 280 degrees. Again, smallest coterminal angle. Very simple operations, add or subtract 360.